Specifically, it's like 3 or something, give or take. So what's f of minus pi? Okay. That goes in the negative part, right? So I get minus whatever I put in. So I put in minus pi. So my output is minus minus pi, which is plus pi. You guys see that this does the same thing you're used to doing? So this is just another way of expressing our rule that we had before. So earlier we had a rule way, which was to calculate the distance from 0. We had another rule, which was this thing. We had a graph, which was this thing. Now we have yet another way, which is this piecewise thing. This is super useful later on. Right now, I know it seems a little cumbersome. What's up?
What about the f of I?
That one's very confusing and a very good question. The answer is 1.
Why?
Because that one is tough. So if you applied this function to I, you have to ask how far is I from 0, right? It turns out that there's a reasonable way, which requires a little calc 2, to draw the complex numbers this way.
Do we need that?
No.
Right now?
No, not at all.
No.
You can ignore this part. So the reason it's 1 is really that when you square I, you get something that has size 1. And then if you do it 4 times, you'll get 1. That's kind of a fundamentally weird thing, and it only happens when the size is 1. This is a very cool question, a little outside this, substantially outside the scope of the class. But. Okay, so all this is optional. Cool? Yeah. Okay. Anything else about absolute values? This is just the absolute value function, right? So if I want to draw a different absolute value function, for instance, let's say we were asked to say graph h of x is minus absolute value x. Okay. So how do I do this? Okay, let's start with a chart. That's a good idea. So I'm going to have x's and h of x's, right? Okay. What are your 5 favorite points? Okay. What do you get when you plug 0 in there? -0, which is 0. Okay. Okay, then 1 is your second favorite point. What do you get out of that? -1. You guys are getting good at function evaluation. This is very cool. 2. What do you get out of 2? -2. This is the part where we might have trouble. Why is it still negative?
Because that's the negative of that.
Yeah, so I'm thinking here, right? Negative absolute value of -1, right? Then I have to do the stuff in the parentheses first, right? According to orders. And those little things, what do those count as? Those count as parentheses. So I have to do that first. So I get -1 means I get -1 out of this. Okay, how about if I plug in -2? I get -2 for the same reason, right? because I do the absolute value first, I get 2, and then I toss a negative on. So, what do I think this thing looks like? Some axes, right? See, so it has the point on it, this guy, y. Zero is both an input and an output, right? And if a thing's on the graph, it's going to be a x comma, no, an x comma h of x pair, right? Right? To be on the graph, their points look like this. So 0, 0 is on here because 0 is the x and the h of x for that first set. What's up?
I thought whatever x was just equal to y. So if we put y, we have to
I want you to put h of x.
Oh.
The reason I want you to do that is I want to label this whole axis y. Right? I want to be able to talk about a point over here that's not necessarily on the graph as an x-y pair. I don't want you to get attached to the idea that y is h of x.
Oh.
Does that make sense?
Yeah.
All right. So we've got 0, 0. What's our next point on the graph? So over 1, down 1. Okay. Over 2, down 2. Left 1, down 1. And left 2, down 2. So what does this look like? Other than sloppy graphing, right? This should look like a V pointed upside down. I was going to have to move something to make that look right. You guys see this? So this thing looks like that one, but flipped over, right? So how about this? Is there a name for this thing? Okay, good, actually. Right, this is 0, 0. So we could call that the origin. That's true whenever we're drawing pictures, right? Whenever we have an XY axis set, that middle point is called 0, 0. In this case, it's called the vertex. Yeah, a vertex and a vortex are slightly different. Right, a vortex sucks up trailer houses or whatever, Oklahoma. And a vertex is the top or bottom of a graph. So, how about this guy? What's that one? That's also a vertex, right? The reason that we care about vertices, vertexes, I don't know what the heck the plural of this word is. The reason we care about these is that they're the tops and bottoms of things. That means they're the smallest this thing got or the biggest this thing got. We're often interested in that because we want to know when things like maximum profit happen or smallest expense. Does that make sense?
Yeah.
Okay, so that's what we're going to start with. So this is what I want you to have out of absolute value functions. I'd like you to be able to graph them. They get a little bit more complicated, but that's something for you guys to play with on your own, I think. Okay? Cool? Okay. You guys want 5 minutes? Okay, let's take 5 minutes.